Hello, let us do a small problem applying functions. This is just in plus 2 level, and this will be useful for IIT examinations. So let me do that. If f from R to R means real numbers, is a function satisfying f of x plus y is equal to fx plus fy for all x comma y in R, and f1 is equal to 7. We have a function from real numbers to real numbers satisfying the rule f of x plus y equal to fx plus fy. This is a rule. And also the hypothesis is f1 equal to 7. Find summation of fm m equal to 1 to k further prove f is an odd function. A function defined in this rule with f1 equal to 7 is an odd function. So let us start with the solution. Let t belongs to R. I'm taking a real number. Then let us work out ft. I can write down ft as ft minus 1 plus 1. Now I can apply this rule. So this will become f of t minus 1 plus f of 1. This is equal to f of t minus 1 plus, but by hypothesis f1 is 7. Now I have a choice to split t minus 1 again. So this I can write down f of t minus 2 plus 1 plus 7. Look at this, t minus 1 is t minus 2 plus 1. Again this is t minus 2 and 1. So I can write down this as f of t minus 2 plus f of 1 plus 7. But we know again f1 is 7. So this is ft minus 2 plus f1 is 7 plus 7, which is equal to f of t minus 2 plus 2 into 7. See, 7 plus 7, I can write down 2 times the 7. It is, the 7 appears 2 times. Let us go a step further. Let me write down t minus 2 as f of t minus 3 plus 1 plus 2 times 7 is equal to, again let us apply this rule. So this becomes f of t minus 3 plus f of 1 plus 2 times 7, which is equal to f of t minus 3. Now I have f1 is 7. So 1 7, 2 7, so I have 3 7s. So 3 into 7. This is 7 plus 2 times 7. So I'll get 3 times 7. If I go on like this, look at carefully. I have started with t. It was reduced to t minus 1, t minus 2, t minus 3. So when I write t minus 3, f of t minus 3 plus 3 into 7 is ft. Now, if I continue like this, the last step I would like to write is t minus 1 plus, look at this, if I write t minus 3, I have to write down 3 times 7. If I write t minus 1, so I have to write down t minus 1 times 7 is equal to ft of t minus 1, so this is f1, is it not? So this will be f1, I get f1 plus t minus 1 into 7, that is 7 plus t minus 1 into 7. So altogether I have 7 times t. 3 into 7, 4 into 7, so t into 7, so I'll get 70. Now I have to write down summation. Summation fm, m runs from 1 to k is equal to m equal to 1, so write down f1 plus f2 plus f3 plus fk. Now f1, what is f1? If you substitute t equal to 1, f1 is 7 plus f2 is t equal to 2, so it's 7 into 2, 7 into 3, and so on. Fk, 7 into k. So what I can write down is, I can take 7 common, I'll get 1 plus 2 plus 3 and so on up to k. Now this is some of the first k natural numbers. So I'll get 7 times k into k plus 1 by 2. Value of this. Now we want to show that f is odd function. So for that, observe the following. Let me write down f of 0 as f of 0 plus 0. And this, by that rule, I have f0 plus f0. So this implies I'll write down f0 as 0 plus f0. So which is equal to f0 plus f0. I have, for f0, I have written 0 plus f0 and f0 plus f0. Now you can cancel f0 on both sides. So you'll get f0 equal to 0. That means 0 will go to 0. 0 is mapped to 0. 1 is mapped to 7. We don't bother whether the rest is mapped to anything. The rest is mapped, you can say, if 100 can be mapped to 7 times 100 into 100 plus 1 by 2. So this is but still we have to prove f is odd. So f0 equal to 0. Now, let us consider 0 equal to f0. But f0 can be written as f of x plus minus x. 0 can be written as, for any real number x plus minus x is 0. So again, apply this rule. This will be fx plus f of minus x. Now you have alpha, you have beta. Alpha plus beta is 0, implies f of minus x equal to minus fx. That's what we have to show. This implies f is odd. What do you mean by odd function? F of minus x equal to minus fx for every x in R. That's an odd function. So that's a very interesting problem, which is a simple application of functions. Of course, I have used the induction value 1 plus 2 plus 3 plus k is k into k plus 1 by 2.